Hello everyone, we are discussing resonance in LCR circuit. And we have developed this frequency at which resonance takes place in the circuit. Now, write down a question. Find out average power consumption. Find out average power consumption at resonance when circuit is in resonance. And the things we have been given are these. We have been given E naught, L, C, R. These are the things which we know, and circuit is in resonance. That means you already know the frequency. Frequency of source is what? 1 upon root LC. For this frequency, try to find average power. You've got around 50 seconds to answer this. Let's see who can. In case you don't remember the formula for average power is given by ERMS into IRMS multiplied by cos of phi. This is the formula for average power. And question is, you need to find this average power when frequency of source is 1 upon root LC. That is, circuit is in resonance. Not a single response. What is the value of ERMS? E naught divided by root 2. What is IRMS? I naught divided by root 2. That's your IRMS. What is I naught? E naught divided by Z. Now, can you tell me the value of Z? What is the value of Z when circuit is in resonance? Write down at least this thing in the comment box. Let's see if you can. What is the value of Z when circuit is in resonance? Write down this fast in the comment box. Good. Z is R. What is the value of phi during resonance? Write down this in the comment box fast. We need phi. During resonance, what is the value of phi? We have done these things in the previous lecture. And I hope you have given this answer that phi is what? 0. Now, what is IRMS? I naught upon root 2, which is E naught upon Z. And don't forget this root 2 part also. I naught is E naught upon Z. And this term of root 2 is already present. So what is IRMS? E naught divided by root 2 and Z, which is R, cos of 0. This gives us average power as E naught square upon 2R. Again, a standard result for competitive examinations. In fact, for any objective examination. Average power during resonance is E naught square upon 2R. Note down this much. And try to learn the way you answer things. When I ask you average power, first thing is you're supposed to remember the formula. Now, once you remember the formula, ERMS, IRMS demands that you must have the value of Z. For resonance, Z is R. Phi is 0. Once you put all these values, you get the answer. Note down this much. And also remember this, that this power is maximum power. This is also maximum average power. So they can ask you that, find out average power during resonance. Or they can simply ask you what is average power and its maximum value. So when power consumption is maximum, you know that circuit is in resonance. Current, its peak value, which is I naught, it takes the maximum. Now, once we have maximum power and all, you can expect a question like this. This is a homework for you. Those of you who are interested can note down this question. We have found that when angular frequency is 1 upon root LC, power consumption is maximum. There is a term which is half power frequency. The homework which I am giving you is write down the homework, find out half power frequencies. Find out half power frequencies. That is, find out those frequencies, that is, those frequencies for which power consumption is half of maximum power consumption. Find out those frequencies for which power consumption is half of maximum power consumption. This is the homework for you. Now, you can understand the homework as well as this graph. Is something which is very important for you. If you are asked to plot a graph of I naught, it's not I, it is what? I naught, peak value. If you have to draw graph of I naught versus omega, what is I naught? I naught is E naught divided by Z. That's your I naught. What is Z? Root over R square plus XC minus XL whole square. That's your I naught. Now, we are not changing E naught, we are not changing R, we are not changing C, we are not changing L. The only thing we are changing is what? Omega. If you are changing omega, then this I naught is E naught divided by root over R square plus XC. Let's write down XC in terms of omega, which is 1 upon omega C, minus XL omega L whole square. This is I naught as a function of omega, and we need to plot its graph. So tell me this, can this graph be of this shape? Or let's answer this way. This is option A. This is option B. This is option C. This is option D. So let's say these are the different graphs between I naught and omega. A continuously decreasing graph, B continuously increasing graph, C. This graph is also increasing, but it has a limitation. It cannot go beyond a particular value. So which option do you think is the correct one? A, B, C or D? Write down this in the comment box. Well, everybody is answering D. So the answer is none of these. None of these four graphs represent the correct graph between I naught and omega. Why? First of all, it's not a straight line. Everybody knows that graph, if it's a straight line, then it is of y equals to mx plus c type of. So this is y, this is x, this is x. So this format is not in the form of y equals to mx. You cannot have a graph of type A. Then this option B, it is continuously decreasing, continuously increasing and taking a saturated value, which I think you thought that this saturated value will take the maximum current. Peak value will become maximum. I think you thought that way, and therefore everybody is answering D. But look at the value of Z, especially the portion inside the bracket. Look at this portion. XE minus XL square. There is something special about this square term. And that speciality is for XE minus XL, let's say 5. If somebody says that XE minus XL is 5, then this thing will become 5 square, which is 25. But if someone says XE minus XL is minus 5, even then minus 5 square will become what? 25. Which means there are two different values of omega for which your Z is same. Look at this. If you take a value of omega for which 1 upon omega c minus omega L comes 5, then this is 25. You take another value of omega and this thing becomes minus 5. Why will it become minus 5? What is XC? 1 upon omega C. What is XL? Omega L. What does it tell us? If you increase omega, then XC is going to decrease. Whereas at this place, if you increase omega, XL is going to increase. Which means when omega is close to 0 over here, this is the axis which is represented by omega. So when you're close to origin, omega is 0. If omega is 0, look at the denominator. Something upon 0 is what? Infinite. So XC is very large. XL is what? 0. XL is very small. And as you increase omega, XC decreases, XL increases. So what is going to happen? Suppose for a given value of omega, XC, let's say is 10. You will understand better with the help of these numerical values. And XL was 5. For a given value of omega, we found this. So what is XC minus XL? 10 minus 5. 10 minus 5. 5 square is what? 25. But now, as I increase the omega, what is going to happen? This XC is going to decrease, whereas this XL is going to increase. And after some time, this 10 becomes 5, and this XL, it becomes what? 10. And therefore, the new difference is what? 5 minus 10, which is minus 5, but square is what? 25. So you are getting the same value of Z for two different values of omega. What does it tell you? It tells you that your graph should be of this type, or it should be of this type. I'll draw a better version later, but just to give you an idea what this whole analysis tells you. And I'm especially giving you the analysis so that any graphical question, if you handle, you can use these arguments. Now, this concept tells us that for two values of omega, you will get same I naught. Look at this. Not necessarily this. You could have taken anything, but just to clear the concept. This is omega 1. This is omega 2. For omega 1, if you look at the black graph, there are two values of omega 1 and omega 2, but you're getting same value of I naught. And therefore, shape of graph should be either of this format or should be of this blue type. Blue type is also giving you the same thing. For omega 1 and omega 2, graph gives us what? Same value of I naught. And therefore, now the option should be, let's say, between A and B. This increasing and decreasing graph, or decreasing and then increasing graph. Because these graphs only will give you what? Same I naught for two different positions of omega, which is coming from this. Now in the comment box, write down Which graph do you think is the correct one for I naught and Z? A. A means decreasing and increasing graph, or B. B means increasing and then decreasing graph. Let's see who can answer this. Well, it cannot be graph A. Why not? Because of this resonance. Resonance tells us that I naught for a certain omega, which is 1 upon root LC, takes the maximum value. If you look at this graph, the black one, graph A, then the graph A says its maximum is what? Infinite. Its maximum is what? Infinite. But you know that at resonance we get a finite value of I naught, or the finite value of peak current, and therefore type A is something which is not possible. Shape of the graph should be of this type. This is the analysis part. Now let me draw the correct graph between I naught and omega. But whenever you find questions based on graph in any objective examination, if you use this kind of logic, then you can easily eliminate wrong options. Draw this thing. Graph is between I naught and omega, and the shape of the graph is of this type. This is omega naught, resonating frequency, 1 upon root LC. When this is 1 upon root LC, this I naught is for the peak current. When angular frequency is omega naught, you get maximum peak current I naught max. What is I naught max? E naught divided by R. E naught divided by Z, and Z you know is what? R. This is the graph between peak current and frequency. This is some omega 1, this is some omega 2, which is telling you what? In this graph, for two different frequencies, you will get same current. As you increase omega, this portion Xc minus XL is initially positive 5, and then it becomes what? Negative. But the square part, it makes both those things same, and therefore you get same peak current. At omega naught, which is 1 upon root LC, your current becomes maximum, which is called what? Resonance. Right at this point, power consumption in the circuit is maximum, which was E naught square upon 2R. And the question I am giving you as homework is what? You're supposed to find half power frequencies. You should give it a try. What is half power frequencies? Let's say omega 1 and omega 2. For omega 1 and omega 2, power consumption, remember power consumption, not the current. For half power frequencies, power consumption will be half of maximum. Again, I'm not saying that current will be half of maximum. I'm saying that for this omega 1 and omega 2, these will be called half power frequencies. For these frequencies, power consumption will be half of maximum power consumption. Note down this graph. And if you understand everything till this point, then write down yes in the comment box. Now, note down this question. Let's do some practice on these L, C, N, R type of thing. We have been given a circuit which is LR circuit. Phi. First tell me phi, it will be 0, greater than 0, less than 0. Which option is correct? A, B, or C? Answer this part. Taking too long. What is tan phi? XC minus XL divided by R. There is no capacitance present in the circuit. This is 0 minus XL divided by R, which is a negative number. If tan phi is negative, that means phi should also be negative, which means option C. First thing you need to remember. Now, we have been told that phi is coming minus of pi by 4. First part of the question is over. You're supposed to get the value of phi, which is coming from this, that should be negative. Now the question says phi is minus of pi by 4. That's the value of phi. R is 10 ohms. 10 ohms. Find out I naught. Find out I naught. If E naught is 20 volts. This is the second part of the question. Phi is coming minus pi by 4. E naught is 20 volts. And you need to find I naught. You've got 30 seconds to answer this. are taking too long. We need to find I naught. How do you attempt a question? If I say find out I naught, what is I naught? E naught divided by Z. That's how you start the question. What is E naught? It's given. So you need to find what? Z. Now you'll think about Z. What is Z? Root over R square plus XC minus XL square. Now there is no XC present in this. You know that XC is not present means XC is what? 0. Since there is no XC present, this is root over R square plus XL whole square. XC gone minus XL square is what? XL square. We have the value of R, 10. If we can find XL, this will give us what? Z. Put it over here and you will get your answer. Now let's see how many of you can find XL and complete the question. And remember the approach, the way questions are solved. But only one person has answered and his answer is correct. What is tan phi? Tan phi is minus of XL divided by R. But what is phi? Minus pi by 4. Tan of minus pi by 4. Now you are supposed to know that if this is negative, then tan minus pi by 4 is minus of 1. Tan of minus theta is minus of tan theta. Tan of minus theta is minus of tan theta. So if I say find out tan of minus pi by 4, it becomes minus of tan pi by 4. And what is tan pi by 4? Tan 45, 1. And therefore you get what? Minus 1. And it tells you what? It immediately gives you value of XL. It gives you XL as R. Negative cancels the negative sign. And your XL is coming what? R, which you already know is 10. So you got the value of XL, put it here, 10 square, it becomes 10 root 2 ohms. We need to find I naught, which is E naught divided by Z. What is E naught? Question has given you E naught as 20 divided by Z 10 root 2. and therefore your I naught is coming 1022 2 upon root 2 amperes. So this is the value of I naught, and that's how you solve these questions. Note down this much. Now the next part of the question is draw phasor diagram for this circuit. Phasor diagram means if I say that if somebody tells us that this arrow represents source EMF E, then you need to draw an arrow for I, for VL, and for VR. If we represent EMF, potential difference, current, these things with the help of vectors, remember they are not vectors, but in phasor diagram we take the help of vector analysis. So if somebody tells us that this is the direction of E, then you need to draw directions of I, VL, and VR. I'm giving you 1 minute's time, and then after that I will ask you whether you have drawn the same thing or not. So try this question. Once you have drawn these things, then I will ask you that whether you have done the same thing as will be shown over here. What's the value of phi? What is the value of phi? Minus pi by 4. What is phi? Phi shows you current which is flowing in the circuit. And the current which is flowing in the circuit is given by I equals to I naught. I equals to I naught sine of omega t plus phi, which is in this case I naught sine omega t minus pi by 4. Minus pi by 4. That means current is lagging behind in phase. Minus pi by 4. This is your presentation for I. Those of you who have plotted I exactly this way, write down yes in the comment box. If you drew same type of arrow system, then write down yes in the comment box. This phasor diagram tells you what? It tells you that I is behind by 45 degrees. I is behind. Phase of source EMF is omega t, whereas current which is flowing in the circuit is omega t minus pi by 4. This is this. Let's see how many of you could solve this. Only 2 are saying they could. No issue. I hope you understand this. Now, you've got 20 seconds to draw VR. You've got 20 seconds to draw an arrow for VR. What was the argument for VR? In alternating circuit, if you have a resistor present, then phase of current and phase of potential difference across the ends of resistor. If a resistor is present, then phase of current and phase of potential difference across the ends of the resistor, they both are same. That means in the same direction you will get VR. Phase of current, phase of potential difference across the resistor, if they are shown with the help of arrows, then both these arrows are pointing in the same direction. Now, those of you who drew VR this way, write down yes in the comment box. And then try to draw an arrow for VL. I try to answer this thing. Draw a phasor diagram for VL. Now let's answer VL part. Phase of current and potential difference. What is the relationship between I and VL? Try to remember this. I hope you remember that for an inductor, current lags behind by pi by 2. If you have an inductor, then current is behind. If you have a capacitor, then current is ahead. So if you say VL and I for an inductor, look here, for an inductor, if somebody gives you current with an arrow like this, then you know that current is something which lags behind. If it lags behind that, this will be your VL, 90 degrees ahead. If this is I, then this is VL. For VR, this is I, this is VR. But we need to draw this thing over here. VL is 90 degree ahead. VL is 90 degree ahead. This angle is also what? 45 degrees. So that's how you will draw VL. Those of you who have drawn the same thing, write down yes in the comment box. And don't forget to note this and this. Above R, you can show this. Above L, you can show this. Now, next part of the question. Find out average power consumption for this circuit. Average power consumption for this circuit. We've got 40 seconds for this. Remember the approach, write down the formula. If I say find out average power, then you will write the formula for average power. And then you will start looking for all those terms which are present in the formula. That's how you answer these questions. So get me average power consumption for a given circuit. Well, I've got only two answers and only one is correct. And the correct answer is 10 watts. We need average power. What is average power? ERMS, IRMS, cos phi. What is IRMS? E naught upon root 2. What is IRMS? I naught upon root 2. Cos phi minus of pi by 4. In case you do not know this, cos of minus theta is cos theta. So you're supposed to do only this much. What is E naught? 20 divided by root 2. What is I naught? Root 2 I naught is root 2 divided by root 2. Cos of 45 degrees is what? 1 by root 2. Root 2 cancel, root 2, 20 upon 2 is what? 10 watts. That's your average power consumption. Now the last part of the question, plot a graph between I naught and omega for this circuit. If you change omega, this I naught will change. Plot a graph of I naught and omega for this circuit. Got 1 minute's time, and then I will plot the graph and you will tell me whether you could or not. Graph between I naught and omega. Look here, hint. What is I naught? E naught divided by Z. What is Z? Z is root over R square plus XC minus XL. XC is not present, only XL is there. XL, what is XL? Omega L. This is something which you need to plot. Now, why did I ask this question? Because many of you will again go for this type of thing. But this graph was present when you had C also in the circuit. Look at this. If I increase omega, there is only one term of omega. If you increase this omega, denominator is going to increase and this thing is going to decrease. Right over here, omega is 0. If omega is 0, this term is gone. You're getting what? E naught divided by R. So your graph is of this type. This place is omega 0, which is E naught divided by R. Omega is what? 0. Gone. You get what? E naught by R. So right here, I naught is E naught by R. But now as I increase the omega term, this denominator starts increasing and therefore graph continuously decreases, and theoretically as omega becomes infinite or very large, this denominator will be infinite and your I naught will become what? 0. The graph is continuously decreasing and this is the shape of the graph between peak value and omega. If you could draw this type of graph, then write down yes in the comment box and then you can leave. Thank you very much.